Welcome again to exciting, ever-fascinating world chemistry. Today we're starting electrochemistry, the process of chemical reactions that produce or require electrical current. Now, first process we're going to look at is something called an oxidation-reduction reaction, a type of reaction where balancing is done based on the electrons lost or gained. There's four terms we need to know: oxidation, reduction, oxidizing agent, and reducing agent. Oxidation is something that loses an electron. Reduction is something that gains electrons. Oxidation is something that causes oxidation by being reduced, and reducing agent is something that causes reduction by being oxidized. So way to memorize that is something called oil rig. What does oil rig stand for? Oxidation is losing, reduction is gaining. So there's a little mnemonic device to help us to memorize this. So here's the steps to do in the process. First, we identify elements whose oxidation is changed. It'll either be an element by itself, metal identified as D and K, center atom of polyatomic ion. Once we identify the number of electrons lost or gained. Check to see if one element on each side. If not, multiply by the multiple. Get the number of electrons equal on both sides. Lost equal number of electrons gained, and then balance by inspection. Metal, non-metal, hydrogen, oxygen, like we always do. All right, so let's look at a problem here. Nitric acid plus hydrosulfuric acid generates sulfur plus nitrogen monoxide plus water. You could do this one through the standard inspection method, but it may take a long time and it may be very difficult to get done. So let's do our process. First thing we're going to do is identify the element by itself. Yes, there is. Sulfur. Any element by itself is oxidation or 0. We come over to the other side. Sulfide is -2 or 2-. So that's a change, and we block it out like that. Now we don't have a metal that we don't know. There aren't any metals in there at all. So next we look for center polyatomic ion. Nitrate is a polyatomic ion. So we're looking for that N, that nitrogen. So we take oxidation of oxygen, which is -2, 2- times 3 is -6. Hydrogen is +1 times 1 is +1. So what number would nitrogen have to be to make that equal 0? The only way to make it +5 is oxidation number. I didn't put it up here. I probably should have. This should be +5. Now we go to the other side. Oxygen is -2, so nitrogen is +2. If this is +5, I didn't put the plus up there, sorry. That's a change, and so we'll go from +5 to +2, that's a change. If I'm going from -2 to 0, that's a loss of 2 electrons. Now it makes sense. It doesn't make sense. Why is it going up, but it's considered a loss? Remember, electrons are negative. So if we're losing electrons, we end up having the number go up. And going from +5 to +2, that's gaining 3 electrons. Make sure there's 1 on each side. I got 1 nitrogen here, 1 nitrogen here. That's good. 1 sulfur here, 1 sulfur here. So that third step is taken care of. Get them equal now. Common multiple 2 and 3 is 6. So multiply the nitrogen, the losing by 3, and the gaining by 2. And we put those 3's in front of my sulfurs, or the H2S, and the S, and put the 2's in front of the nitric acid and nitrogen monoxide. We then balance by inspection. I've got no metals. Nitrogens, I got 2 and 2 were good. Sulfurs, we got 3 and 3 were good. Hydrogens, I got 2 plus 6, that's 8. I've got 2 on this side, so we've got to put a 4 over here to balance it up. Now lastly, 2 times 3, that's 6. 2 and 4, that's 6. It's balanced. The last thing we need to identify for this is oxidation, reduction, oxidizing agent, and losing agent, reducing agent. Well, remember, oxidation, oil rig, oxidation is losing. That's going to be my sulfur because sulfur is losing. Reduction is gaining. Reduction is nitrogen. Nitrogen is gaining. Which one caused oxidation by being reduced? Which one's reduced? Nitrogen. Which one caused reduction by being oxidized? Which one oxidized? Sulfur. There we go. All right, so copy these down. We'll do these in class. Nitrous acid plus hydroiodic acid yields nitrogen monoxide plus iodine plus oxygen, and potassium dichromate plus water plus sulfur gives potassium hydroxide plus chromium 3 oxide plus sulfur trioxide. That's it. We're done. Take care. Be good. Bye.